453%. That is how far Cambricon's revenue needle moved in a single year, on a company that had never once closed a fiscal year in the black. The export controls on advanced data center chips arrived, the losses continued for years afterward, and then in 2025 the instrument inverted. One metric, two readings, one ceiling that now defines how far the inversion runs. Years of red, 453% up. First profit, booked. The then reading sits across multiple fiscal years. From 2022 through 2024, Cambricon reported net losses in every period. Its revenue base was negligible relative to the size of the domestic artificial intelligence chip market it was nominally competing in. Chinese data centers, where they could obtain allocation, preferred Nvidia's high-end data center processors. Cambricon was designing chips, taping them out, and paying for verification cycles, licensing, and engineering headcount on a revenue line that did not come close to covering those fixed costs. No domestic Chinese artificial intelligence chip designer had reported a profitable fiscal year in the accelerator segment through the end of 2024. The binary was zero. The now reading is dated 2025. Cambricon reported 453% year-on-year revenue growth, and the company crossed into profit for the first time in its operating history. The binary moved to 1. The reading did not improve gradually, it inverted in a single reporting period. And alongside the revenue figure, the company put forward a unit shipment target of roughly 500,000 chips, a number that represents approximately a threefold increase over prior annual output. The distance between the then reading and the now reading is not a drift, it is a step function. The mechanism behind the inversion is substitution, not organic demand growth. Nvidia's highest performance data center processors were subject to export controls that restricted their sale into China. The controls did not eliminate demand for that class of compute in Chinese data centers, they eliminated the preferred supplier of it. Cambricon, as the most mature domestic artificial intelligence chip designer with an existing software stack that engineers had already learned to program, absorbed a large share of the procurement spend that could no longer reach Nvidia's top-tier products. The revenue line is the shape of that redirected spend. It is not a record of buyers choosing Cambricon on merit over an available alternative. It is a record of buyers choosing Cambricon because the alternative was unavailable. That distinction matters enormously for reading the ceiling on what comes next. 453%. The vacuum made the number. Substitution-driven growth has a ceiling defined by the size of the vacuum it is filling, not by the quality of the product doing the filling. Once the redirected procurement has found its new destination, the growth rate must revert to something closer to the underlying expansion of data center compute demand in China. The 453% is a one-time inversion reading, not a sustainable trajectory. The question the metric cannot answer on its own is how much of the vacuum remains unfilled and how many other domestic competitors are filling the same space simultaneously. The profitability crossing is a different and more durable signal than the revenue growth rate. Artificial intelligence chip design at advanced nodes carries enormous fixed costs. Tape-out fees alone, the cost of producing the initial set of masks that the fab uses to manufacture the chip, run into the tens of millions of dollars per design iteration. Add engineering salaries, licensing for design tools and intellectual property blocks, verification cycles that can run for months, and the capital burden of maintaining a competitive design roadmap, and you have a cost structure that requires substantial revenue volume before any margin appears. Cambricon covered those fixed costs with domestic revenue alone in 2025 without needing access to foreign markets. That was not true in 2024. It is true now. The business model is self-sustaining at current Chinese market prices and volumes. That is a more durable fact than any single year's growth rate, because it means the company does not require a continuing procurement crisis to survive. It requires only that its current customers continue purchasing at current volumes. The profitability crossing does not, however, confirm that Cambricon's chips are competitive on raw performance per unit of power consumed against Nvidia's current generation. Those are two separate measurements, and confusing them is the most common error in reading this company's financials. A company can be profitable while producing hardware that delivers substantially less compute per watt than the leading alternative. It happens when the price differential is wide enough and when customers are willing to accept the efficiency trade-off rather than go without compute entirely. Profitability confirms that the business model works at current Chinese market prices and volumes. It does not confirm that the hardware would win a competitive benchmarking evaluation against unrestricted alternatives. The constraint migration is the reading the 453% figure does not state directly but implies. In 2021 and 2022, the binding constraint on Cambricon's revenue was customer preference. Buyers chose Nvidia's data center processors where export licenses permitted, and Cambricon's design quality and software ecosystem were not sufficient to displace that preference on merit. That is a demand-side constraint. By 2025, the binding constraint had moved one layer upstream in the supply chain. Customers now want Cambricon's product. The limit on how many units Cambricon can ship is not how many customers will place orders. The limit is how many wafer starts the fab will allocate. Think of the fab's wafer capacity as a pipe of fixed diameter. For years, Cambricon was pushing less through the pipe than it could carry. Demand was the constraint, and the pipe sat partially idle for Cambricon's purposes. The export controls opened a valve on the demand side. Suddenly, more was being pushed in than the pipe could pass. The pipe did not change. The pressure behind it did. The 453% is the pressure reading. The 500,000 unit target is where the pipe walls are. That migration from demand constraint to supply constraint is itself a significant reading. It means the design problem and the sales problem are for the moment solved. The unsolved problem is silicon throughput, and unlike the design problem or the sales problem, Cambricon cannot solve the throughput problem unilaterally. It does not own the fab. It competes for wafer starts at SMIC alongside dozens of other Chinese fabless chip designers working in automotive, communications, industrial computing, and consumer electronics. Every wafer start allocated to Cambricon is a wafer start not available to those other customers, and SMIC manages that allocation across competing demands that have nothing to do with artificial intelligence chip economics. The 500,000 unit target, roughly a threefold expansion over prior annual output, is the demand-side number. The actual shipment figure that will appear in subsequent reporting will be set by how many wafer starts SMIC allocates to Cambricon in the relevant production windows. Analysts who follow SMIC's capacity utilization describe the 500,000 unit figure as supply-limited rather than demand-limited. That means the interesting number to watch in the next reporting period is not the order count. It is the shipment count against the target. The node gap between Cambricon's manufacturing process and Nvidia's current generation persists and is material. Cambricon's chips are manufactured at SMIC on process nodes that are multiple generations behind the leading-edge nodes available to Nvidia through its foundry relationships. The gap in computational density and energy efficiency between those two process positions is substantial and well documented in the semiconductor industry literature. What is notable about the 2025 reading is that this gap did not prevent the revenue inversion. The economics worked anyway, at current Chinese market prices, and at the performance per watt trade-off that Chinese data center operators were willing to accept given their procurement alternatives. The assumption embedded in the original logic of the export controls was that maintaining the node gap would prevent domestic Chinese artificial intelligence chip economics from becoming self-sustaining, because without access to leading-edge process nodes, domestic designers could not build chips that data centers would actually deploy at scale. The 453%, combined with the first-ever profitability crossing, is evidence that this assumption was wrong for this market segment and this price point. The node gap is real, it is measurable, it did not prevent the inversion. Those three facts coexist in the 2025 reading, and the tension between them is where the interpretive work lies. A buyer who cannot obtain an Nvidia high-performance data center processor and installs multiple Cambricon chips to approximate a comparable compute throughput shows up in Cambricon's revenue and unit count as multiple units sold. That figure flatters the revenue metric relative to what is happening at the level of individual racks in the data center, where operators are consuming more power and more physical space to achieve throughput that a leading-edge chip could deliver in a smaller envelope. This matters for reading the long-run ceiling. The substitution works at current prices. It may work less well if power costs rise, if data center space becomes constrained, or if the performance requirements of the workloads being deployed shift toward tasks where the efficiency gap between process nodes becomes the binding variable rather than the price gap between available options. The margin of error on the headline reading has three components. The first is the gap between reported and verified. The 453% figure comes from Cambricon's own reporting. No independent shipment count, no third-party customs data cross-reference, and no external teardown analysis has confirmed the unit volumes that would be required to generate that revenue at known market price points. Company-reported revenue from a strategically significant firm in a sector, subject to export controls and intense policy scrutiny, is exactly the condition under which reported figures and externally verified figures have historically shown the largest divergence. The instrument is reading Cambricon's own gauge, not an external one. The second component is the performance per watt gap. Revenue growth measures what buyers paid, not what they received per joule of power consumed. The 453% growth rate is consistent with a range of scenarios at the rack level, from buyers getting reasonable compute throughput at an acceptable efficiency penalty, to buyers running significantly underloaded infrastructure relative to what leading-edge hardware would deliver. The revenue line does not distinguish between those scenarios. The third component is that the ceiling is moving in both directions simultaneously. SMIC is adding capacity at nodes relevant to Cambricon's product line, which would expand the pipe. But Nvidia, though restricted from selling its highest-tier data center products into China, continues to advance its architecture and process technology on leading-edge nodes unavailable to SMIC. If that advance accelerates, the performance differential between what Cambricon can manufacture and what Nvidia is building widens further, potentially changing the price-performance calculus that currently makes the substitution economically viable for Chinese buyers. The node gap that currently allows Cambricon's economics to work at Chinese market price points could compress if SMIC catches up, or expand further if the leading-edge pull continues. Both movements change the reading. The synthesis is this. The instrument reports what it can measure, which is a revenue line that inverted, a profitability status that crossed for the first time, and a unit target that is supply-constrained rather than demand-constrained. What it cannot measure is whether profitability holds when buyers eventually face more alternatives, whether the performance gap becomes more consequential at larger deployment scales than it is today, or whether SMIC's capacity curve rises fast enough to sustain the growth rate rather than compress it. The measure's plain read is straightforward. The restriction that was designed to keep the domestic artificial intelligence chip sector unprofitable did not hold on the timeline it was designed for. Cambricon crossed into profit while the node gap that provided the original justification for the restriction remains in place and unmoved. That is not a projection about 5 years from now. It is a reading already on the instrument dated 2025, sourced from the company's own reporting and not yet confirmed by external verification. The wall did not hold the revenue line flat. The restriction redirected procurement, and the procurement redirected the reading. 453% is what that redirection looks like on a single company's income statement. Years of red. 453% up. First profit, booked. The gap between the then reading and the now reading is already in the record. What remains open is whether the next constraint, the one upstream at the fab, gets resolved before the growth rate tells you it was not. Watch for Cambricon's unit shipment figure against the 500,000 unit target by the end of 2025. If the reported shipment number comes in short of the target despite documented order demand, the fab ceiling is real, the supply constraint is binding, and the growth rate compresses in the next period. If the shipment count clears the target, the pipe got wider, and that is a materially different reading about what SMIC's capacity can now support. That one number will tell you more about the durability of the 453% than any subsequent revenue headline will. If you want to read the next instrument before it moves, subscribe and turn on notifications, because the next dated reading arrives when that unit count closes.